Hello everyone, my name is Roy Jafari and I would like to welcome you to another video. In this video we are going to continue our journey in developing fundamental Python programming skills. In this video we are going to talk about functions and see many different aspects of this very useful concept and functionality of Python. Alright, let's look at the video. Okay, so we actually have used some functions in the past videos. And the reason for that is actually functions are very simple. For instance, you can, with 2 lines of code, create your own function. So for instance, I say def, which stands for define, and give my functions a name. For instance, I say hello. And you always have to have parentheses in your function. Functions are sort of like a syntax, correct syntax, and also they're like known with having open and close parentheses. We do see that this open and close parentheses can remain empty, which means that your function doesn't have an input. We will see soon examples of that our function does have inputs, but for now we just leave this empty, right? So then we print hello world, right? So as simple as that, we were just able to create a function. Now we can simply call the function. So by just typing out the name of the function we just created, we can call the function, and what's going to happen, it's going to run whatever is in the function, and this hello world print is going to be printed, right? So as simple as that, right off the bat we start creating functions. So that's very simple. Creating function is very simple. So like I said, this can remain empty for us to do something, or we can accept input. We call them input arguments. So for instance, instead of saying hello to the world, I can say hello to someone. So I grab the input of name, and this time instead of saying hello world, I switch the word into something that I want to fill in, and I use this string format function that I've been using in the past videos that we're going to also talk about in one of the future videos. It's basically whatever you put here is going to put here. So as simple as that, right? So whatever this name is, it's going to be printed, right? So now my function has an input. So once I create this and I call out, say hello to, and now give the name of Roy, right? So my name. So once I run this, now say hello Roy. Or I can use with other names, right? So for instance, hello Ruholda, right? So this is going to also work. We don't have to limit ourselves with one input. We can have as many inputs as we want, right? For instance, I want to update my function to include first name and last name, right? And now I make this a little bit more complex. Now it has 2 placeholders, so I pass first name and then last name. Now once I run this function, pay attention, now this function needs to have 2 arguments, right? So if I were to just say hello to Roy, this is going to give me an error. It says, what is the last name? You just gave me a first name, right? So I have to pay attention. Now I have to give both first name and last name. And now it gives me, say hello Roy Jafari. I could have passed this as one collections of items. For instance, I could have changed this, code. I could have, just said name, right? And I know that this name I'm going to be passing is going to be a list or a tuple, whatever is that collection. So I would say name 0, the first part of that collection, and name 1, right? So now I can just pass, right? So when I'm calling it, I can just pass, for instance, a list, of the inputs that I want to use in this function. And now it's going to say hello to me. Or I could have passed a tuple, right? It doesn't have to be a list. So whatever is collectible and indices make sense for it, such as tuple and list, is going to work here, right? Hello to Jafar. So next we are going to learn about something that we have already seen. This is basically another way of sort of calling a function, right? So let me bring this function, right? So I want to recreate this function. So this is my function. I could do this, of course, this is going to work out. I could say Roy and Jafari, right? So this would work out. But I also could be a little bit more specific about the inputs I'm providing. For instance, I could be saying something like last name is equal Jafari and first name is equal Roy, right? So it doesn't matter which one comes first, and it's more specific and explicitly I'm saying what I am assigning to what. And once I run this, it's going to run also correctly. So whatever you have as name, you could be passing it when you call a function. A very useful functionality of Python is that it allows you to have arbitrary inputs, and basically you could sort of like have any value you want, right? So when you say star, the input, right? This is going to accept anything that you give, right? If you have 1, 2, 10, however many input you want, it's going to be provided in this sort of like tuple during your function running. So here, all you would need to do, since you are using arbitrary input, you would be using this name as a tuple, right? So the first part of it is sort of like name. We are passing first name, and then we are passing last name, right? So once you run this, now once you say hello to, and if you pass Roy and then you pass Jafari, then it's going to say hello to Roy Jafari, right? So what is the difference between doing it this way and doing it like a tuple, right? You remember we had this, we would pass this as we would sort of like keep an eye on this being a tuple or a list, whatever, right? So it works. And the difference is now we are easier. It's easier for us to pass whatever it is that we want to pass, right? So we are not confined by just having to either do a list or a tuple, right? We don't have to do that. We basically pass, as many values as you want. Like for instance, I can be, also providing my another name, right? And this is just going to run without giving me an error, right? So basically, it's going to ignore this part because I'm not using it. I'm only using the first and the second sort of like input arguments and inputs. So that's the advantage of using arbitrary input. So now in this situation that you're using arbitrary inputs, you might want to sort of like give a heads up to whoever is using your function that you're ignoring the third arguments or whatever it is, right? So in those situations, we would be raising a warning or error. In this situation, raising a warning is better. The difference between a warning and an error is that when you raise a warning, you're going to allow the code to still run, but you're also producing a warning message. But with error, it's going to stop the running of the code and just going to give you the error message. All right, so let's produce a warning if someone did pass more than 2 inputs, right? So this is our function, and I'm going to import the module warnings. And if this is, like I said, going to be a tuple, right? If the length of the name, right, is larger than 2, then I'm going to raise a warning. So I would say warnings dot warn, and then I would pass a message, something like the function only uses the first 2 inputs, right? Then with also, I mean, it's not gonna stop the processing of the function, but it's just going to also give a warning. So if I run this, but this is going to give me a warning, right? This is exactly the message I created. So you know, creating warning and errors are useful when other people are going to be using your functions, or it could be that your future self is going to use this function and you might just forget. So that's when you would, you know, sort of like start thinking about including warnings and errors in your code. But how about here we also practice raising an error? How about making sure that only strings are passed here? If anything other than a string was passed, we want to raise a value error, right? So let's do that together. So I'm going to keep the warning, right? So let's keep the warning. But after, before we check for the warning, let's check if everything is actually a string. So right, so let's actually loop for you know, name in, let's call this names. So I have to switch everything to names. Actually, that's what I intended. So for names in names, right? If name, the type of name, which is one of the you know, arguments, one of the inputs, is not str, a string, then you raise, right? Raise an error, raise value error. The function only work on strings. One of the input, actually say one of the inputs, we would say, you know, whatever it is that we inputted is of type, right? And then I would say format. So let's go to the next page. Format, then this, whatever it is, name, and then type of it, right? And now let's just run this, right? So now we included also a mechanism to raise an error if the value is passed is not string. So let's go ahead and give this a test. So let's pass a value of 2, right? So once you run this, it says the function only works on strings. Give the value error. 2 is of the class type integer. That's why it's not run, right? So now I have also a period at the end. Now we all want to talk about the keyword, arbitrary keywords argument, right? So with the arbitrary inputs, right, we would access these like you know, like a tuple, right? So this would be the first value, then the second value. If we were to use 2 stars instead of 1 star, and now we can also access the arbitrary you know, inputs with the name of the whatever it is that we are using in the function. So let's see an example. I think that would explain this much better. So let's update this one, right? So actually not that one. Let's update this one. So here, now I'm using 2 stars. Now here, instead of saying 0, I say first name, and instead of 1, I say last name. So once I create this, now I can say hello, right? and say last name is equal to Jafari and first name is equal to Ruhollah, right? So once I run this, I need to run this first, last name, this is name. So that was the error. It says there was no last name. There you go. Hello, Ruhollah. Another very useful way to create functions is using default values. Default values could be used when you want to use a default, but also you want to give access to changing this default to whoever is using this function. One thing that we've been using as default, but we don't have access to it, is this greeting. So how about we sort of like do this, but also provide an access to whoever is using this function. So let us update this, right? So I would say greeting, right? And default equal, so that's how you would define an equal. You would say the default is hello, right? And now here, instead of doing that, you would also print greeting. You would add it to your format. So now if you were to run this, it looks like that nothing has happened. But what has happened is the fact that now you can access the greeting. You can switch that. You can instead say, hey, use howdy for me this time. Right? So once you run this, you say howdy. You see how brilliant this is? You can give access to the default. But if someone didn't want or didn't know this existed, your function would still work pretty smoothly. One thing I want to bring your attention to before moving from this default thing is that the values that are not sort of like arbitrary keywords argument, if you have anything but then you have arbitrary keyword argument, they have to come first. You cannot have anything come after the arbitrary keywords argument, right? Keywords argument. This is going to give you a syntax error, right? So this everything comes, and then at the end you can have that. Okay. So just something to pay attention to. Let me also have this to show that this would work either way. All right, now let's talk about the very important returning a value. So far, every function that we have been writing in this video, we have not returned a value. We've been printing, which is, it shows something, it prints, it's an action, but we haven't been returning value. And that's actually a very useful functionality of function to be able to return things. So at the end of your function is done, return something instead of printing or instead of doing something, right? So let's, for instance, create a function that counts the number of R's in a string. Number of R's, right? And we pass in a string, I call it S, and then I return, right, the list count R, right? And also I would make sure that I am also counting the both capital R and lowercase r. So this would actually work. Let's just give this a try, right? So I call this and here right, so this is going to just work fine. It counts the number of R's, but I could have done this better, right? I could have, instead of this doing this twice, I'm casting this string as a list twice, right? I could have said L, or the list that I'm using here, right? Do this once, now use this value. So this is a much better function computationally. So it would give me the same answer. So this is one way I could have done this, just sum these two up, but I also could have returned more than one value, right? I could have returned the number of capital R and the number of lowercase r, right? So by just separating them with a comma, I'm returning these two. So once you run this function, call it, right? So I've updated the function. Now once you run this, it gives you two output in a tuple, right? You could, let me say output, right? You could access the output like a tuple. You could access the number of, those R's, capital R and the number of lowercase r's. Exactly like this, right? You could also have sort of like taken things into your hand and we could have passed a list, right? So if you do this, you would pass a list here, right? So if you would rather have a list, right, you could just pass as a list, right? The same thing, you could access these values as well. You could actually have done something even better. You could have pass or return a dictionary, right? So let's update this and return a dictionary. Well, I would do something like this. I would say R, the capital R, this is the value for that, and the lowercase r, this is the value for that. And once we run this, now our output is going to be much more intelligible, right? So it's going to actually give us the dictionary. Now let's say we get this into an output, right? And now you could do all sorts of things. You could say, what is the output? It shows you everything. You could say, output, I want the capital R, or I want the lowercase r. And it gives you all those answers. Another thing we want to learn in this video is we want to learn about recursive functions. Recursive functions are perhaps a little bit advanced at this level for you. At this point, if I'm pretty sure you can follow, but creating them, once you actually need them, might need a little bit more experience with programming. But this is good at this point that such things exist in Python. Not every programming language allows recursive creation of functions. That basically means when you have a recursive functions, Python allows you to call the same functions in itself, right? So let's just look at an example. So I'm going to actually create a function iteratively, which is not recursive, and then we'll see how we would do that in an iterative way. So do you remember we talked about factorial? So let's create that function. We want to create a function that would calculate the factorial of n. And the factorial of n is the multiplication of all of the numbers from 1, 2, 3, all the way to n, right? So if I want the factorial of n, I would need to create a product, and I would need to loop in all the way from 1 to n, right? So that's why from 1 to n plus 1. And I would need to do this production, right? So multiply equal to I. So at the end of it, I would just return R, right? So that's the iterative way of doing this. The reason I'm showing this is because I want to, after this, show how this can be done recursively. This is product. Alright, so this is the answer, right? So this is the iterative way. Let me put a comment here, iterative approach. Alright, now let's do the recursive approach. and I'm going to call this function r.recursive factorial, and I'm going to receive or like input n, and I would start the product from the back n, and then if the n minus 1 is larger than 0, I want the product to be equal to the multiplication of n minus 1, right? Else actually n larger than 0. Else I want to return 1. I want to return product multiply by n minus 1. So if you pay attention to the logic here, you would see that by calling the function itself, it starts into a loop, the function itself, that eventually would create the n factorial. So let me run this, and let me run this new function and see if we get the same answer. There we got the same answer. Like I said, this might be a little bit over your head as far as how you would go about creating this, and I don't think this is the right level for you to actually get your teeth into it. Just wanted to let you know that these recursive functions exist, and all there is to it, from a high level perspective, is that you would call the function itself in the function, and it would allow for you to create iterations by this logic. Alright, so let's move forward. The next thing we want to talk about is the existence of two types of variables, global variable and local variables. And basically global variables are variables that are defined before the function is defined, but you're going to use them in the function. But the local variables are the one that you can only define them and use them during the function. Right? So for instance, when you have different environments that your program is going to be run, for instance, different language, right? So for instance, let's say we have a global variable of language. Let's say it's Farsi, right? So now when I create my say hello to function, right? So I want to create this function, define this function, and let's grab names, and so now I can use this global value to sort of like curate my function for these different possible languages. So for instance, I say if this global variable language is equal to Farsi, right, then my message I want to be a little bit different. My message I want to be and names. How about no, that's good. Names, first name, names, last name, right? And else, any other language, I want the message to be in English, right? Just as an example, right? So it would be hello. So basically this is salam in Farsi, which is hello in Farsi. And then I would print the message, right? So once I create this, now I have this global variable, right? So this is global variable, and I'm using it inside the function. So your function depends on the fact that your function needs to run in an environment, run in a kernel, that the value, the global variable language has already been defined. Pay attention to that. So now I can say hello to, the language is Farsi here still, right? I could now use Farsi stuff. Let me add these. All right. So I say last name, and then first name. The reason is we are using double star, which is arbitrary keyword input. So we need to use keywords. So last name Jafari or Jafari, and first name Ruhollah. Alright, so once we run this, last name, there we go. We have an error here. Let me fix it. Alright, there we go. Salam Ruhollah Jafari, which is hello Ruhollah Jafari in Farsi. I could have used the same function when the language is French, right? So here I would say, for instance, the last name is Montagnier, and the first name is Thomas, right? So now that I'm running this, I'm going to say hello Thomas Montagnier. Thomas Montagnier is actually one of my friends, and if you're watching this, hello Thomas Montagnier. Alright, so that's global versus local variable. Next things we want to talk about is how we can use functions for collaboration and teamwork, and working on the same project using programming on a team. So there are a few functionalities and tools that we can use if we want to work on the same programming project in a team. Of course, one of them is using comments. I've sometimes been using comments. So this is a comment, and basically it means it's just for whoever is going to look at the code. It's going to sort of help them understand the code. For instance, I know this is a global variable, but this does not run. It's just for the eyes of whoever is going to be looking at the code. It could be your teammate, or it could be yourself in the future, right? So that's how we use comments. We could also be using the keyword pass in this way. So for instance, we put a comment something like this. This function needs to be created, right? So you are working on a team, and you know that this function needs to be created. Get peaks, right? And for now, you just want to sort of create it. You don't want to just leave it empty, because if you did leave it empty, it would give a syntax error. So you would just put pass for now. If you run it, it's okay, but it's nothing, right? So that's basically how this keyword pass is used. Another function, another good thing that Python has that you can use is doc strings. Basically, when you create a function, you can add some documentation about the function. And the way it works is you have 3 quotations. So once you have 3 quotations, this is basically your opportunity to document something about your function. Say what the function is doing, what's the function supposed to be, or whatever communication you want to have, but you don't want to run. So for instance, you could say, we need to write a function that capture the index of peaks in variation, right? So and then you close it with 3 quotations, and now you see it works like a comment. It's not going to run, right? So that's how it works. You could also change this into multi-line. It doesn't have to be one line, right? So you can have more stuff. This is temporarily assigned to Roy. However many you want to add here. So that's also a very useful way to sort of communicate when working on that. It's a team project that you're working as, and you want to use programming. All right, so let's finish this video with an example. We want to write a function that takes n as a number and calculate the products of its digit. The function only accepts integer and otherwise gives a value error. And then we want to try the function with these 2 numbers. All right, so let's get started. So we want to define, product of digits, right? And it takes n, right? So we want to first get access to the digits. We could be doing it by dividing it by 10 and getting the remainder, but there's an easier way that we've actually seen in the previous videos, and that is to cast the string as a list, right? So let's see how this would work here. So you've got this number, right? So once you do this, actually cast it as a string. So once you do this, now you've got these strings, and now you can access these characters. So let's call this S and cast it as a string, and then for char in S, which each character, or we can actually change it into digit, and let's do this as NSTR. I mean, it's the same thing, it's a number but in a string, right? So we are accessing each digit, and of course we want to calculate the product, so we have to create our variable that we are going to use in this loop. So now product multiplied equal to this digit, which is in a character, so we need to change it to integer. And once we are all and done, we can return this product. So that's the function. We can give it a try, see if it's worked so far. So we can use it on this one, right? And it does work. But also the question says the function only accepts integer, otherwise gives an error. So we have to check that if the input is integer, right? So before we get into the function, we have to say if the type of n, right, type n is not integer, we have to raise value error saying the function only accepts integer, and the input is of the type, input is we can use a format function to say actually what the input is. Input is type n, whatever it is, right? So once we run this, this is still going to work because this is an integer. But how about if we were to use the other one? Is this going to work too? Let's just check. Once we run this, it gives a value error, our own value error that we created. The function only accepts integer and input is float. So this accepts, there we go. So now this is our error. Alright, so in this video we covered a lot of material and a lot of different aspects of creating functions and how we could actually use them using a couple of examples. Alright, until next week.